What's up, guys? So now we're going to talk about how to do the limits. But of course, before doing that, we need to know what is limit of a function. Limit is the value that a function approaches as the input approaches some value. In formulas, a limit is written like this. So we could read as the limit of f of x as x approaches c equals L. The fact that a function f of x approaches the limit L as x approaches c is denoted by a right arrow. A function is a relation of one set to another. So, if the values of f gets closer and closer to 1, and only one number L as x takes values that are closer and closer to n. So, let's start and do some limits. In evaluating limits, the first thing you need to do is to substitute. Very simple. Let's consider this function. Limit of 2x minus 3 as x approaches, let's say 2. So what can we get? So in order to do this, we need to substitute 2 to every x in our function. So it's gonna be look like this. 2, substitute 2 minus 3. And what will we got? 2 times 2, 4, minus 3, we'll get 1. So that's how you just do the limits. But this is actually simple limits or easy limits. Let's do another example of simple limits. So we have limit of 3 over x squared plus 2x minus 2 as x approaches to 2. So we're just going to plug in the value of x of every x in our function. So it will be look like this. Minus 2. So if we calculate this, we will have 3 over 6, or simply 1/2. And that's your answer. Okay, but what if we get an answer 0 over 0? So let's consider this example. First, substitute, right? Minus 6 over 3 minus 3. So obviously, we're going to get 0 over 0. But don't put this answer in your test papers. Don't write this an answer, because this is one of the common mistakes that students do. They put 0 over 0 as their answer. I tried this once, and my teacher actually put question marks on it because 0 over 0 isn't an answer. It's indeterminate, okay? So let's just put in mind that the answer of this example is 0 over 0. No need to write 0 over 0, okay? So back to the question, what if we get 0 over 0 just like that? What can we do? So having an answer of a form of 0 over 0 is actually we can use an algebraic technique that will help us find the solution. So these are the examples. Factoring, or it's a polynomial or rational function. We can expand multiplying things, and if it is fractions involved, you can get their common denominators or multiply by conjugates or use trig identities or special limits or involving trig or e. For this example, we can factor this out but only the upper part because the lower part is a 1-degree polynomial. So it will look like this. X minus 3, right? X plus 1. And we could just rewrite the lower part, which is x minus 3. So as you can see, we can cross this out and rewrite what's left. And it's x plus 1. So this makes it easier because you're just going to substitute 3 to the x for a function. So it will be 3 plus 1. And the answer we're going to get is 4. So that's the answer. So for the next example, limit t minus square root of 3t plus 4 over 4 minus t as t approaches to 4. So as you can see, we didn't use x anymore, but actually we can use any characters we want, or it's a, h, z, x, or even delta x. So now, as you can see, if we plug in the value 4 to the every t in our function, it will also resulted as 0 over 0. But of course, we're not going to write that, but we're just going to simplify it. So as you can see, when you see square root in numerator or a denominator, remember that we need to use the technique of rationalizing or rationalize the function. And by doing that, and yes, because we're rationalizing, we need to change the sign of the function in the second term. And by using that, we're going to use the numerator. So it will be t plus square root of 3t plus 4 over same t plus square root of 3t plus 4. Okay. So, after doing that, we're just going to multiply each of the term. So that would be, this would be t times t will be t squared. And the 2 square root would be negative 3t plus 4 over 4t t plus 3t plus 4. So as you can see, we didn't really multiply the denominator part of each of the term, because if we do that, the whole equations will be too much complicated, and you're going back by factoring it out and rationalizing it out, and it will be too much complications. So we didn't multiply the denominator part. So as you can see, in the numerator, it is a 2-degree polynomial, so we can actually factor that into this. Limit x at t approaches to 4. So we can rationalize that as t minus 4 and t plus 1 over, just copy that, 4 plus t t plus square root of 3t plus 4. Okay, so as you can see, we can cross this out, and what do we do next? Of course, we need to rewrite the what is left, right? So what is left in the numerator is t plus 1, and for the denominator is the t plus square root of 3t plus 4. So as you can see, we already simplified the equation. So because we already simplified it, we can now substitute 4 to every t in our function. So it would be 4 plus 1 over 4 plus the square root of 3, 4 plus 4. So now we're just going to add this up and calculate everything. So 4 plus 1 will get 5, and 4 plus square root of 3 times 4 plus 4 will get 8. So the answer is 5 over 8. So as you can see, if we did multiplied the two denominator, we could have canceled the we could have the canceling technique. So it would be more complicated if we did. So yeah, we got the answer 5 over 8. There are actually rules of limits. So it's best to remember those rules, but not just by remembering them, but also understanding them in order to avoid complications in evaluating your limits. But what if we are given a one-sided limit? We can only say that if a function is continuous at c when these three conditions are met. Okay, now let's consider this function, and it actually has a situation here, as you can see. So before answering these function, we need to identify first which direction does this each function goes, like the 2x squared, as x is greater equal than 1. So the x is greater equal than 1, so it means the direction of this function is actually going to right direction. And the x and the 3x minus 5, as x is lesser than 1, so this direction goes left. Okay, so after identifying which direction each of the function goes, now we're going to use the three conditions that was said before. Okay, so the first is we need to identify as x approaches to 1 positive. You can um, you can start with the direction of left, the negative, or right, which you prefer. You can use any one of them. But I'll go first with the right directions. As you can see, the function with the right direction is 2x squared. So I'm going to put 2x squared here, and then just substitute 1 to the x squared, and we're going to have the value or the answer 2. Okay, after the right direction, we're going to find the value as x, the limit as x approaches to 1 to the left side. So the left side is, the equation of the left side is actually 3x minus 5. So we're just going to substitute 1 again. 3, 1, minus 5. And we'll get negative 2. So as you can see, the two limits with different directions doesn't really have the same answer. So it only means that the limit of x as approaches to 1 does not exist. Okay, in order to show that this equation does not exist, we're going to put it in a graph. So the graph will look like this.